Hi everyone, I am Durga Devi, Assistant Professor from SNS College of Pharmacy and Health Sciences. In this video, I am going to describe about the methodology involved in paper chromatography. It involves the application of sample development, separation, detection and visualization. The paper chromatography is done with the help of stationary phase, Wattman filter paper, and the mobile phase can be either polar or non-polar solvent. And the types of paper chromatography can be classified into adsorption type and partition type. In adsorption type, the paper will be coated with another adsorbent material such as silica or alumina. In partition type, the moisture that is present in cellulose in Wattman filter paper will act as a stationary phase, and normally the partition type is chosen as its principle generally. The principle of separation is partition. The sample which is having more affinity or more solubility towards the mobile phase will move at a faster rate, whereas the sample which is having the less affinity or less solubility towards the mobile phase will move at a slower rate. And the separation process is given here. The stationary phase we can use for Wattman filter paper number 1, 2, 3, 17 and 20, and based on the sample we can do some modifications in paper also. We can use acid or base washed papers, hydrophilic papers or hydrophobic papers, which is chosen based on the sample. And the paper consists of 98 to 99% of alpha cellulose, 0.3 to 1% of beta cellulose, and then size we can use is of any suitable size with suitable chamber we can use for chromatography as a stationary phase. Then the category of stationary phase is papers we can use are Wattman filter papers number 1, 2, 3, 17 and 20. Its composition is 98 to 99% of alpha cellulose, 0.3 to 1% of beta cellulose, and the modifications are acid or base washed papers, glass fiber, hydrophilic, that is glycerol or glycol coated papers, and hydrophobic ones, that is silicone coated papers. And the size can be of any size kept in suitable chamber, impregnation with silica or alumina or ion exchange resins possible. The mobile phase can be either pure solvent like methanol, acetonitrile water, or buffers such as phosphate buffer, acetate buffer. And the mixtures also we can use like isopropanol, ammonia and water mixture, butanol, acetic acid and water mixture. The choice is based on polarity and the substance nature. The sample application. The sample will be first dissolved in the mobile phase at lowest concentrations to avoid the large zones. Then we have to apply them with the help of capillary tubes or with the help of micropipettes. We have to keep the spot as smaller as possible in order to get better separation. And the development techniques can be classified into ascending technique, descending, circular or radial, first development and then second development. In ascending technique is like a normal paper chromatography where you have to keep the mobile phase in the chamber and the paper will be kept immersed inside that mobile phase. It will travel against the gravity. And in descending technique, the buffer or mobile phase will be kept at the top and the paper will be hung down from the chamber where the development will be taking place towards the gravity. And in ascending and descending, two mobile phases will be kept, one at the bottom and another one at the top. This is like for separation of complex mixtures we can use, like it is like a continuous development. First the development is done ascending wise and then the development is done in descending manner. Then circular or radial paper chromatography involves the use of circular papers where you have to keep a spot at the center, and with the help of cotton wick the mobile phase will start moving, spreading in zones along the paper, and the different components can be separated in one-dimensional and two-dimensional technique. Suppose if you are having a complex mixture, first you have to develop them like ascending paper chromatography. Then after the spots has been developed, you have to turn them as a 90-degree manner, and you have to keep it again inside the chamber and have to develop another method. So the complex mixtures can be separated in this manner. Then the detection techniques are categorized into specific and non-specific techniques. So in non-specific techniques, the methods used are iodine chamber method, UV chamber method, and UV chamber with the help of fluorescent stationary phase. And in specific methods, we can use specific reagents such as ninhydrin or any other reagents that are suitable for specifically identifying the compounds we need to separate. And the RF value can be calculated with the formula distance traveled by solute divided by distance traveled by solvent. The applications are, we can perform purity check, impurity detection, cosmetic analysis, food contaminants, and drug metabolites. Thank you.